Here's a quick review of the concepts that we're going to use in this module. In kinematics, we saw that when an object moves in a circle, the velocity vector is along the tangent of the circle, and the object also has an acceleration that points towards the center of the circle, and it's called centripetal acceleration. Its magnitude is related to the velocity, always, and it's equal to v squared over r. R here is the radius of curvature of that circle. Of course, we also know Newton's second law by now that says that sum of all forces have to add up to the mass times the acceleration. That has to apply for all directions, and in this case we have a very special direction that points towards the center of the circle. That's the radial direction. So one specific application of Newton's second law along that direction will give us that all the forces that have any radial components, once you add up those components, they have to be equal to the mass times the radial acceleration, which we usually call centripetal acceleration, and it has a value of v squared over r. Now this expression here, all the combination of those forces along the radial direction, sometimes are called centripetal force. Do not get confused. Do not confuse this force with the other forces. This is more like an office. At any given instant, one or a combination of forces that we saw, gravity, tension, normal force, or anything like that, must serve as a centripetal force. So the centripetal force is not a new force. It's just a combination of previously known forces that will combine along the radial direction to cause that centripetal acceleration. So with that, I can say that the sum of the radial components of all forces has to be equal to mv squared over r. So this is what we're going to use in this module. Also, in this module, we will actually touch on static friction again, so you need to review that from the previous modules here. Remember, the static friction is different from the kinetic friction. Static friction refers to the friction when there is no sliding between surfaces. In other words, there's traction, so the two objects are in contact and there's no sliding. This is very common scenario in everyday life. While we normally don't like kinetic friction, the static friction more often than not is our friend. You drive your car and you want static friction between the bottom of the tires and the road. You walk and you want static friction between the soles of your shoes and the ground. So remember, when it comes to static friction, there is no slipping, there is no sliding, and the static friction could be anywhere between 0 and its maximum value. The maximum value is determined by the coefficient of static friction, mu s, so that the maximum value of the static friction is always mu times the normal force.